We found the domains of various functions of one and two variables, but now let's look at an example where we find the domain of a function of three variables. Looking at the right side of the equation, we can immediately see that the function will be undefined if the denominator equals 0. Now we need to look at each portion of the function. There is a fourth degree radical in the numerator and a seventh degree radical in the denominator. Radicals with odd indices are defined everywhere, so this doesn't affect the domain. However, the radical in the numerator has an even index, so its radicand must be non-negative. There is also a natural logarithm in the denominator that is only defined for positive values. Both radicands, as well as the argument of the logarithm, are polynomials, which are defined everywhere. Let's start with our first condition. When will the denominator be 0? The denominator is the product of a logarithm and a radical, so it will be 0 if either factor is equal to 0. Let's look at the denominator from left to right. When is the natural log equal to 0? Remember, the logarithm of 1 is equal to 0 regardless of the base. So, the natural log of the quantity xz squared minus 7y is equal to 0 when xz squared minus 7y is 1. Our first restriction on the values of x, y, and z is that xz squared minus 7y cannot equal 1. The second term in the denominator is the seventh root of the quantity negative 5xy cubed z plus 8xy squared z to the fourth plus 3z to the fifth minus 12. A radical with any index is equal to 0, only when the radicand is 0. We now have a second restriction on the domain of f. Negative 5xy cubed z plus 8xy squared z to the fourth plus 3z to the fifth minus 12 cannot equal 0. The second condition is that this polynomial cannot be negative. This gives our third restriction on x, y, and z. 3x to the fifth y squared minus 8x to the fourth z squared minus 7yz plus 8 must be greater than or equal to 0. Our final condition is based on the argument of the natural log. The natural log function will be defined for all points in the domain as long as xz squared minus 7y is greater than 0. Using the restrictions found above, we can now state the domain f. The function is defined for all values of x, y, and z in R3 such that xz squared minus 7y is greater than 0 and not equal to 1. Negative 5xy cubed z plus 8xy squared z to the fourth plus 3z to the fifth minus 12 does not equal 0, and 3x to the fifth y squared minus 8x to the fourth z squared minus 7yz plus 8 is greater than or equal to 0.